At now the application of integration in kinematics. Kinematics is the study of motion involving forces, but we don't consider external forces, we consider only the motion. So acceleration is given by change of velocity with the time. So to get velocity, what we do, we integrate velocity with respect to t. To get velocity, we integrate acceleration with respect to t, as shown here. This symbol stands for integration. So when you differentiate your function and you differentiate it, building and demolishing, building is integration. When you are differentiating, you are demolishing. So when you demolish and build, you get what we had initially. So our velocity is got by that plus a constant. Now, velocity is given by rate of change of displacement with the time. So to get displacement, we integrate the velocity. And again, when you are integrating and differentiating, you are going to get your displacement here, which is a vector quantity. That way. So this is mostly understood by giving a simple example. A ball is thrown upwards with a velocity of 40 meters per second. So determine an expression in terms of t for its velocity, its height above the point of projection. Now, here what you need to understand is that whenever you throw an object upward, the velocity will be negative because that object is moving against the gravity. So dv over dt give us acceleration, which is equal to -10. We take acceleration due to gravity as 10 for convenience. It is exactly 9.8, but for the purposes of convenience and calculation, we are going to take acceleration as -10. So to get velocity, we integrate this function with respect to t, and we are going to get v is equal to -t plus c. Now, initially, when the ball was thrown, the time was 0, and the velocity we are given, it is 40 meters per second. So where you have v, you substitute with the 40, and where you have t, you substitute with the 0. So 40 here, v is equal to 40 initially, t is equal to 0. So -10 times 0 is 0, meaning that our c is equal to 40. You substitute here. So our v will be equal to -10, our c is 40. So we have answered Roman 1. The expression in terms of t for its velocity, it is that one. Now, change of displacement with the time is equal to our velocity, this one. ds over dt is equal to 40 minus 10t. So to get displacement, we integrate this equation with respect to t. And now we are going to have 40t minus, this is t squared divided by 2. T squared divided by 2. So we want 5 divided by 10, -10t squared divided by 2, we will get -5t squared plus c. Now, initially, at t is equal to 0, then displacement is 0. Before any time it elapses, then displacement is equal to 0. So use that condition. T is equal to 0 when displacement is equal to 0 to get our c. We substitute here. So 40 times 0 will give us 0. -5 times 0 squared will give us 0. 0 minus 0 is 0. So c is equal to 0 because displacement is equal to 0 initially. So meaning that our s is equal to 40t minus 5t squared. So that is its height above the ground, above the point of projection. The height is given by s is equal to 40t minus 5t squared. So the maximum height attained by the ball, is given by v is equal to 0. So 40 minus 10t is equal to 0. So t is equal to 4. t is equal to 4. So the maximum height attained by the ball. So height is maximum when the velocity is 0. So we use this equation for the velocity. We equate it with the 0 to get the value of t. And when we equate this one with the 0, we are going to find it out from here. This is what we are doing. We are 40 minus 10t is equal to 0, meaning that 40 is equal to 10t. So you divide by 10 both sides to get t is equal to 4. So our t is equal to 4 seconds. Once you get your time as 4 seconds, the next thing now which you need to get is the question is the maximum height. So you substitute here. Our time is 4. So 4 times 40 times 4 here is 160 minus 4 squared is 16. 16 times 5 is 80. So 160 minus 8 is 80 meters. So that is how you obtain it, and that is how calculus is applied in that is integration, application of integration in kinematics. So that is how it is easily applied and you get your answer. So thanks so much for your time. Let us keep on learning. This is calculus for beginners and it is applicable for grade 12. So I hope this video is beneficial to you. Kindly consider subscribing and liking and commenting and even sharing with other scientists so that you can continue learning together. You can also share with me the areas which you think I should cover, and I will be willing to tackle them on your behalf as I meet your needs of mathematics. Thanks so much. See you next time.